All right, we're going to do a quick demonstration today on a 13D calculation using vCALC from Viking. So let me go ahead and switch on over. So I've got some of you who are familiar with our Fire Sprinkler CAD Basics Bootcamp will remember or recognize this is our sample ranch home, our first. It's usually what people start on going through our boot camp. And we're just gonna do just a real simple two-head calculation using Viking vCALC. So I'm gonna go ahead and click on create a new project. And I'm gonna fill this stuff out real quick just so you guys can kind of see how it populates the final report. So this is our sample ranch home, if I can spell. And we're making up an address. I'm taking this too far. I'm leaving all this information the same. One thing of note while we're here, this button at the bottom, vCALC runs the calculations like live as it's going. So you might want to turn that off for whatever reason. If you hit this button, it says right here, calculations are disabled. Otherwise, as we're inputting data, it will be putting kind of like error information in there. I'm just going to leave it enabled. You notice first thing it says is our source static pressure must be greater than 0. So I guess I'll just go ahead and go to supply and put that in. I'm just going to use an 80 static, 75 residual, and 2000 GPM just to make sure this thing works for this example. You know, your water supply information will vary by, and I'm actually going to call one of the things I do like about vCALC is it lets you name nodes whatever you want. And so I'm going to name the supply node source. And supply name, I'm going to call it city main. Now we're not going to have hose allowance because this is a 13D project. So now it's giving me an error down here. It says supply node must be present in the start column of the pipes table. Well, let's insert a pipe section. I mean, this thing is kind of set up to where more for it wants you to work from, it makes sense to me anyway for you to work from the sprinklers back to the source, because they have like end node and then start node, and the way these carry on automatically as we drop down. I think you'll see as we go along, but I just named these S1 and S2 for our sprinklers since we can with this program. It's kind of nice sometimes to, you know, designate sprinkler 1 and 2 or whatever you want. But for our workflow at MCAD, we use all numbers for the nodes, and that is just because we have different guys using different calc programs, and to keep uniformity across all of our drawings, it's just easier to have everybody set up using as close to as possible the same node naming system. But I do kind of like calc software that lets you use letters in the name. So let's go ahead. I might be able to zoom in a little bit. Let me see here. So we're going to put in S2 and S1. And one thing I don't really like, I mean, I don't know, it's okay. And a lot of other programs have this too, in calc programs, but you know, I was just hitting tab, it worked for the first couple buttons, but then it skipped way across to over here. I really need to go here with the mouse. I wish I could just do it with the keyboard. To me, that'd be faster to have that as an option. But once I have this set in here and we keep going, you'll see that it's pretty quick. So we're going to go with 1-inch blaze master. It's giving me correct internal diameter of that is 1.101. And let's see. One thing that's a little bit cool about vCALC, I will say, is that it will, create a graphic representation of your calc, and you don't have to do it. It's optional, but if you want that to work out, you need to use this box right here that's asking for direction, and it's just defaulting to positive X, and that happens to be correct. We've got this X, Y coordinates here, so this is from, down going up would be positive Y, from the left to the right would be positive X, and then the opposite of those would be true as well. Negative Y is going down, negative X is going from right to left. And then up and down is our Z, so going up is going to be positive Z, and going down is going to be negative Z. So from going from S2 to S1, that's X positive, so that's good. That's correct. And we are at 11'1". If I just go to our section real quick, we measured that. If you're in the boot camp, you're familiar with this project. We've already established that. So we are at an elevation of 11. I don't think it'll let us do inches or like 2 degrees of decimal to put, like, because it'd be 0.08. Let's see if it'll let us do that. Oh, it does. Okay. Excellent. And then 11.08. What's next? Is that the last thing we can do right now? Okay. Oh, component. Okay, so let's click here. We actually don't have any, but this is where you would put in elbows and T's, and we're going to do a water meter and a watts double check valve here when we get to the end. So now that we've got this much in, we can just, instead of clicking on insert empty section, we can go to here and hit plus, and it's going to copy all of the information from this row, which is very nice. It saves us some time. And it also is going to automatically bring down our S1 from the previous line and put it in the end note. This part's a little bit backwards, where it has end and then start. I keep getting that confused in my mind, but that's why, to me, it's easier to work backwards through the system. I think as long as you could keep this straight, you could work through it in either direction, but for me, it's much easier going this way. So next, from S1, we're going to go to 8, and we're really only going to 8 because, oops, not 6, 8, oops. The reason we're going to 8 is so that we cannot have this thing draw it in 3D unless we put a node at every change of direction. It's not necessary for the calc to come out right, but for the diagram to be shown correctly, it is. All right, so this time our distance, the 9'1" plus 2'5" is 11'6". So 11.5, and we're still going in positive X direction. We're still at 11'1" in elevation. Let's see. We do, though, this time have a component. We're churning. Now, some could argue if that's an elbow or a T, depending on your school of thought on that. I'm just going to put T because it's going to be more conservative. It is a T fitting that it's going through. That's going to give us equivalent length of 21.06, where if we did an elbow, let me get rid of the T, oops. That one elbow is only 15.3, or wait, 3.83 equivalent feet. I think I might have read the wrong box. 3.83 equivalent for an elbow. And 9.56 for the T. So the total at this point is 21.06. So anyway, all I'm saying is, all it's doing for an E or a T is adding the equivalent of straight length of pipe. So the T is more conservative. This fitting it's going through is a T, but, some would argue that you should only be a T if you're going through both directions of the T. It's up to you. I'm not going to argue with that with you. I'm just going to do it because it's more conservative and I'm less likely to get questioned by it by a plans examiner in my mind. But let's keep going. So 8 to 7. Now again, we're going to have the same situation. It's a T. Do a T. We're only going one through direction though with the flow of pipe. So let's take a look here. Let's add, copy this one, go 8 to 7. Again, it's Blaze Master 1 inch. Elevation is still, I don't know, the length, what is that? It's 12 now. Elevation is still 11.8. And again, I'm putting a T because it's more conservative than an elbow, but I could see good argument to just call it an elbow, and if that's what you do, that's fine. Now let's go, and didn't go far enough over. I'm going to hit the green plus to copy this row. It's going to bring the 7 down. I'm going to go 7 to 6. And again, I'm only doing these changes of directions with a node so that it will create the 3D image you're going to see. It's really not necessary. We could go all the way from S1 to the top of riser, just like we would normally do with another program, anything else. But by doing this, it's going to create a 3D image of what we're doing. So one thing, 8 to 7, I forgot. We changed our direction here. We're no longer going X positive, we're going Y negative. So let's change that before I forget. 7 to 6, that way is 5'6". And again, we are going in the positive X direction. And this time I'm definitely going to put an E instead of a T, because there's an elbow on the end. And no, it's not going 90 degrees through a T like those other ones. All right, so now I'm going to go 6 to the top of the riser. So I'm going to copy this line. It's bringing the 6 down. I'm going to go TOR for top of riser. Let's see, 1 inch. The length is 4 feet, it looks like. And the direction is going to be negative Y. And the elevation is still 11.1. Yeah, and still an elbow on the end of there. That's good. All right, let's copy this line. Now we're going to go TOR to, let's call it BOR for base of riser. Next one. And we're still going to be 1 inch Blaze Master. Some guys I know like to build their own rather than use a pre-purchased like riser assembly. They kind of like to build the riser out of steel, just because it's, especially like here in Oregon, a lot of times they'll be in the garage, and so it's kind of like makes it a little more stout. Not everybody does that though. Some guys just do them out of plastic, whatever, stick them in the wall. So anyway, I'm just gonna leave it Blaze Master. You might want to change that to like schedule 40, depending on what you're doing. One thing we do have in there is a double check valve. So let's see, the distance we're going, we were at 11.1, but in elevation, we're going down to 3 foot of bury. So that would be 14.1, and then we're going negative Z. Our ending elevation is -3, so that's good. The only problem I don't understand what's going on here is it did it in the wrong spot. So let's go. I might have done something wrong. We'll see. This one is -3. Okay. Supply node must be present. Okay, I haven't gotten to supply node yet. Okay. Let's go. So now we've gone down. We're at -3. Oh, we need to add. Elbow is good. There's an elbow at the bottom. We also have this watts 007 I'm going to add. Hit OK. So now that's in there. And then I'm going to go and copy that line. We're going to go BOR to 3. Traveling with 1-inch Blazemaster CPVC underground. 1-inch diameter. Let's see. Pipe length is 13. And it's not -Z. It is positive X. Still at -3. We don't have the watts anymore. Just an elbow right here. Okay, now I'm going to copy that one again. Then we got 3 to 2. And the distance is 48 feet. And we are going in the -Y direction. Still -3. That's buried under the ground. And let's see. So elbow, this time we don't have an elbow, but we do have a water meter. And this is actually, I added this using the component manager here. It had under accessories, water meters. This was already set up with Neptune water meter, but it didn't have any curve data in here for it. Oh, I guess it does for 1-inch. That's it. Okay. So I guess we could have used that. But I just used, it's probably very similar. Out of NFPA 13D. Actually, if we go right here, the table 10.4.4a, and I just put that into generic water meter rather than saying Neptune water meter. And right here, I just put in these amounts right off of that table. And so that's where it's pulling that info for the water meter. All right, so let's go now from, see, that was 3 to 2. Now we're going to go 2 to 1, or let's call this source. All right, 2 to 1. We'll add 2 to 1. Oh, no, not 1. We're calling it source. And it's not 1-inch Blazemaster. It's 3/4 inch copper. All right. There's not a water meter. Okay. So that's the whole thing put in. Now it says down here, please define a design area. So let's go to Design Area tab and click on Add Design Area. This little pop-up box came, says New Design Area Name. And since we calced this area called Kitchen Dining, that's just what I'm going to call it. Okay, now add a sprinkler. It says node unassigned. I'm going to call it S1. K factor was 4. We're using a residential sprinkler. We'll say a Senju 4.9. Now, density, it's 0.05. Area, I'm going to put in 256. 7 for minimum pressure. You'll notice, I guess, I don't think I need to, but real flow and real pressure is below because we're at 256. I have to actually change this to 60 to get these so that they will work. So, one thing about that, this isn't what puts it on your report. This is just what is determining your actual flow in your sprinkler. So understand that, like, you know, because we don't want the plans examiner seeing on the calcs, oh, 260 square foot spacing. What kind of head is that? It doesn't make any sense. But we had to increase that with the 0.5 density to get that up to 13 GPM. So now let's copy this for S2 and we'll just call it S2. But we'll have an opportunity to where we put on the report how much we want it to say that the sprinkler is covering. We won't automatically put this. This is just basically determining the flow, as far as I can tell anyway. If you have more experience, feel free to comment. Let's see. What does it say down here? So, calculation finished successfully. 75 iteration. 0 seconds. Safety margin 21.89 psi. So that's pretty fantastic. It's already ran it, you know. So we've got up here, I'm guessing this run calculations button must be if you have them turned off, maybe. I don't know why. Just ran them again and did the same thing. Sure, there's a point where you run into where you'd want that if you maybe changed stuff and it hadn't updated, but it seems like it does it pretty automatically. That I did an update recently. I hadn't used vCALC in a while, and I don't think that button was there. All you did was click on this one, the printer, to create submittal. That's what we're going to do next. Oh, actually, I forgot. Before we do that, this little 3D cube, let me zoom in a little better for you guys. This is a 3D cube. Here's the create submittal button. We're going to click this, but I'm going to zoom out so you can see what it does. Opens up this other menu. And if you have multiple screens, this is nice to like put full screen on a different monitor. But I'm going to zoom in, and this is pretty sweet. This is showing a 3D representation of our calculation, which by looking at it looks like, you know, I've just playing around with this over the last few days, and a few times I did it and didn't realize I messed up on an elevation or something, and once you went to this diagram I saw it immediately. So I think this is pretty handy, and we are going to I'm just kind of positioning it so it fits the best in here, and then I'm going to click on this button up here that says screenshot. And it's saying enter name for the picture. And man, I guess there's lots of reasons, you know, different ways you could name it. I could see, like, if you were doing multiple calcs, like say you did we're doing a 2-head calc in the kitchen dining, you might want to do a single head calc in the bedroom so that you can do a 20 by 20, because you might not be able to get that with, you know, 2 heads, but you might be able to get it with 1. And so, you know, you might be building 2 calcs for that reason. And so, you know, this is a diagram of kitchen dining. It basically makes the most sense to me to just name it the same as what you named the design area, but maybe you have good reason to why you would want to name it something else. So I'm just going to call it kitchen/dining. Okay. And now I'm going to close this. And when I click on this printer button, I'm going to zoom back in again so you can see that. The printer. This box comes up. And over here, there's this option for screenshots. And so that one that I just did and named kitchen dining is here. And so I can select it. It's going to be included in the report. And I'm going to include the curve details. I want that in my report. Project information filled out automatically from earlier. Design has some stuff. It has the kitchen dining name. Remote area location is kitchen/dining. Occupancy classification residential. Density. Now this is where it's going to add this information to our cover page. Area of application, 2 sprinklers at 256 is 512. Coverage per sprinkler again is 256. Type of sprinklers calculated, we're gonna be using Senju. I think they're SS8464. We could put that right there. Number of sprinklers calced, it has 2 automatically because that's what it calced. In-rack demand does not apply for a 13D system. Type of system, usually on a calc program, this is referring to wet or dry, and we're putting wet. We've got some good information here about our safety margin and our supply. Okay, so, you know, you might have, I'll have to put today's date, location, you know, you might have the address where the hydrant was flowed, intersection of whatever, section of no name lane and IDK Boulevard, you know. The source was sprinkler contractor did the flow test. You know, you might put the name of your company or whatever is the situation, the company you're doing the design for. And, you know, contractor. And their address, I don't know what it is. It doesn't matter. And I'm just going to go ahead and hit print. And it's going to open this up as a web page, basically. Oops, my viewer looks like it's been updated. And I don't know why I opened it twice, actually. That's kind of interesting. But it's got all my info here, my whole calc. It's got my diagram, which is pretty cool. I like here, I could see, you know, pretty easily. I got my flow test information with my system demand and a big safety margin there. Yeah, so this isn't bad. It's, you know, but how do you make a report from this? You just right click, hit print, and, you know, I have Microsoft Print to PDF as my printer selected, and it's just going to make an 8-page report with all of this information. So you just hit print, and then it will ask you where you want to save that. I can just put it on my desktop. Here's one that I did a while ago. I'll just change to today. Oh, that was a couple days ago. Let me just hit save. And let me see if it'll pop up here quickly enough. There we go. All right, so there is our report. Let me zoom out a little bit. Ready to be printed out on an 8.5 by 11 for submittal to your jurisdiction. All right, that's it for this demonstration. Thanks a lot, guys.